Hello students, this is Dr. Singhal here. As an attempt to do this offline, I'm going to describe writing of a function in this video where function takes arguments both by value and the reference. In the class we might have done functions only that take value, parameters by value or by reference, but this one will take both and there is a need for that. So let me first state what we are trying to do in this function. You can read this portion of ebook, page 32 or 33. Your copy might have different page number, but there is this topic called more example of pass by reference. And what we are trying to do here is we are trying to find roots of a quadratic equation using functions where we pass values from the main to the function by reference. And of course there are values passed by value also, parameters passed by value also. This is how we want to understand this problem, that this is the definition of a quadratic equation. If you don't know much about quadratic equations, you could actually type on the Google quadratic equations. Spelling is that quadratic and equation, and Wikipedia will have pretty good articles on that. So make sure you understand what quadratic equations are before attempting this. But basically quadratic equations has a form like this: ax squared plus bx plus c. It's a very famous equations in algebra, and basically its solution is given. Actually I should show you the solution. So just hold on a second, I will type that. Okay, so for equation that is ax squared plus bx plus c equal to 0, the two solutions which are called roots in mathematics would be, one will be x1, another will be x2, and the difference between x1 and x2 would only be this sign here. In one case this is plus, in other case it's minus, everything else is same. But the key thing here is that we are taking a square root of this quantity here. This quantity is called discriminant, and you get a real root only if this quantity is positive, which means b squared minus 4ac is positive. It could of course be 0 or negative, and know that you cannot take square root of a negative number. In that case we get the imaginary root. So this program we are writing does not deal with the imaginary roots. We are going to make sure that in our function we do some computation only if this is positive. So that's the first thing we're going to check. Okay, so let's go back to the Microsoft Word document where we have the details. So quadratic equation is shown like this. We are required to write prototype and the definition for a function, get real roots that returns a Boolean value of true if there are real roots and false if there is a imaginary root. And it's going to take 5 parameters as argument: a, b, c. These are the 3. These will be integer type, and we need 2 more parameters to return 2 real roots. We are not computing the imaginary roots because then we'll need too many parameters. We are not making this function that complicated at this time. So a good solution here is that we can pass 3 parameters by value, which are the integers a, b, and c, and the 2 roots that function is going to determine, we are passing them by reference, which is the floating point type. Okay, so the prototype of the function will be this, and remember that in prototype you don't really need the name of the arguments, you just need the data type. So this will be passing the a, this will be passing the b, this will be passing the c, this guy over here. Main function will not have a value attached to this parameters and this parameter, those will be empty. And function will actually determine them for the case where there are real roots, which means this quantity here is actually positive, and then return the true. Otherwise, if this quantity is negative, it's not going to fill in the value for this parameter and this parameter, which means these won't have a outgoing value or incoming value. All right. And in that case, we'll just return a false actually. Okay. So function takes 3 incoming values a, b, c from the calling block, and it calculates 2 outgoing values, root 1 and root 2 for the calling block. This is root 1 and root 2, and they are the 2 real roots of the quadratic equations that has coefficient values a, b, and c. All right. So we have written this function already. I'm going to take you to Visual Studio and show you the function and show you how we designed it and why it would work. So this is the Visual Studio code, and if your video is minimized right now, you should maximize it to make these fonts a little bit bigger. Actually, I'm going to make the font bigger and come back. Okay, so this is the prototype for the function getRoots. It returns, notice it returns a Boolean type, true or false. And these are the parameters a, b, c, which are the values of a, b, and c, a, b, and c in the quadratic equation. Okay, user is going to enter those. All right. So we get ABC. So first we determine this b squared minus 4ac. In mathematics, this is called a discriminant, and it's really this quantity over here. And we have to make sure that this is positive to find the roots, otherwise we return a false. So we determine the value of b squared minus 4ac, and if it is actually indeed less than 0, we output the message that you will have imaginary roots, which we don't want to deal with, and we return the false. And in a more complicated program, we could deal with that, by the way. I might do that and give you a copy of that. So if discriminant is less than 0, I print that to console and return false. Otherwise, I can just use my sqrt function to take the square root of discriminant. In this case, discriminant is int type. We multiply by 1.0 to cast it to a floating point type. In up to Visual Studio 2010, there was a problem that you could not get the square root of an integer. That problem has been removed in Visual Studio 2012. So we have two roots, minus b plus square root of discriminant divided by 2a, and minus b minus square root of discriminant divided by 2a. Those two roots are here. I'm calling this as discriminant, which was already determined over here. So that's the math behind it. So I don't need to recalculate it. It's already calculated here. And I just take the square root of floating point form of this. And then, since else block is executed, I return true. And that's pretty much my function. It'll only work. It'll return a true when roots are not imaginary, they're positive roots. Okay, so we're going to write a main for it, and then I'll come back and explain to you how the main works. Okay, one more thing I want to point out to you, that a, b, and c are passed by value, so they only have an incoming value. Root 1 and root 2 are passed by reference. They don't have an incoming value, but they may, depending upon whether discriminant is greater than 0 or not, they may have an outgoing value. Okay, so when we pass by reference, we need to keep track of that. Is there an incoming value? Is there also an outgoing value? Or is there only one of them? Okay, so let's go back to Visual Studio. So this is our main function. So we define these 6 variables, a, b, and c. Those are the a is the coefficient of x square, b is the coefficient of x, c is the constant. And we use them as an integer type. That's the convention. You can use them floating point type, but integer is better. And we have this variable which will store the return value from the getRoots function. If it will be true if roots are real, otherwise it will be false. We set it to an original value of false actually, and we set the root 1 and root 2 to some floating point 0 value because we don't really know what they are at this point, so we just set them to 0. Okay, and we just set fixed so point, set precision to formulate these two values. Okay, then we ask the user, this program will determine the real roots of a quadratic equation. All data you will be entering would be whole numbers only, and then we ask them to enter coefficient of a that's gotten here, then coefficient of x squared, then coefficient of x, which is b, and the constant c. And once I have that a, b, and c by the user, then I just call the getRoots function and pass them a, b, c, and root 1 and root 2, which function will determine and return by reference, means it's just going to copy the values here. Since we are passing by reference, these values will be changed. Okay, and you already saw the function that a, b, c are passed by values, so this discriminant will be determined, and if discriminant is less than 0, we just print that, return false. Otherwise we compute the roots and return it true. If true is returned, here's the function call to the function. If true is returned, then this if statement will execute and it prints the value of root 1 and root 2. If it is false, we don't need to really do anything because we already printed imaginary roots here, so we really don't need to do anything. Okay, so let's run this program, and I'm just gonna give it some values. A bunch of warnings, but shouldn't be a problem. Okay, so here's my console, and I have to be careful that b squared minus 4ac is positive, and that can be done easily if I have both b and c negative actually. So I'm just going to say 2 minus 5 and minus 4. And it does have two real roots. One of them is 3.137. Second one is negative root, which is 0.637. Okay, so that's one outcome. I'm going to copy that. You'll have a copy of that. But of course, there is a possibility that b squared minus 4ac is actually negative. In that case, we'll get the negative imaginary roots. And I can easily simulate that by making the c a positive and large number and b as a positive number also. So let's do that. So a, I can just put a to be anything, let's say 5, and b, okay, should be positive number, so let's say 4, and c a positive number, let's say 10. Yeah, minus 4ac, so that should really work. And in that case, I get the message that I have the imaginary root. Okay, so the important thing in this function is that it takes parameters by value, which have incoming value only, but by reference as well, because while functions called at that time, they don't have any values or 0, but then since these values are altered, there will be outgoing values. And remember, when we pass by reference, the memory address is passed, the variable memory address is passed, so function can change the values, and if that happens, then those are printed here. Okay, so this is another example of passing data to a function by value as well as by reference. Okay, so hopefully you understand that a little better now, and I'll have this example available on D2L. Thank you so much. Bye.